And this assistant of mine, in case of a failure which takes place, the assistant of mine should be able to, on its own, back order the required parts.
In 2023, we have entered the augmented age.
Today, technology is a compulsion and no longer a choice.
Prescriptive maintenance or predictive maintenance is one aspect in which AI can be used in a big way.
And it requires a lot of collusion effort in terms of recording your baseline signatures and then recording a real-time digital information coming in, then superimposing it, then inferring, and then triggering an alarm.
Jai Hind, viewers. Today from MRO Digest Forums, we bring you another very interesting panel discussion on AI in MRO. We have a very distinguished panel with us today. We have with us General N.B. Singh, who served as the Director General of the Corps of Electronics and Mechanical Engineers, Director General Information Systems, and was a founder member of the Armed Forces Tribunal, Jabalpur. He specializes in armored fighting vehicles and played a key role in the design and development of bulletproof vehicle Takshak Arjun armored recovery vehicle and made significant contribution in the development of Dhanush gun system. He has undergone specialized training in Germany on off-highway vehicles and served in Moscow as military attaché technical. We are also hoping that General Kapil Aggarwal will be joining us. He retired as the Director General, Corps of Electronics and Mechanical Engineers, a postgraduate from IIT Kharagpur. He also served as Chairman, Army Pay Commission, Cell, providing the inputs required by the 7th Pay Commission. General Aggarwal also served as the technical advisor to the government of Mauritius for close to 3 years. We have with us also Lieutenant General Dr. Anil Kapoor, who served as the Director General Electronics and Mechanical Engineers and Director General Info Systems. A chartered engineer, he was awarded the Eminent Engineer Award 2020 by Institution of Engineers. He is a professor of practice at IIT Tirupati and also a board member in their Innovation Hub. He writes and speaks on emerging technologies like C7 ISR and AI in many publications and platforms. We also have with us Lieutenant General TSA Narayanan. He was commissioned in December 1982 and has more than 40 years of experience in technology, education and training, research and development, MRO and administration. As Commandant, Military College of Electronics and Mechanical Engineering, he organized a national seminar on AI for prescriptive maintenance and also undertook large number of AI projects. He was the chief architect for demonstrating the offensive swarm drone concept during Army Day Parade 2021 in collaboration with a startup. And we also have with us Major General Ranjit Ghosh, who served as Additional Director General and Colonel Commandant of Corps of Electronics and Mechanical Engineers, a postgraduate gold medalist from IIT Madras in maintenance engineering. He was Chief Managing Director of Army Base Workshop. At strategic level, he steered a life cycle engineering support for Army's capital acquisitions, revenue procurements. And also, he has authored books on global defense industries and technology basis, and is a strong proponent of disruptive technologies for defense transformation. So to start with the discussion, may I request General TSA Narayanan to kindly give us his views on how do you think AI will impact MRO? General Narayanan, please.
Thank you, sir, for the introduction. Sir, as I would like to say what all in NCME we did in AI, and that will basically tell you how it's going to impact the MRO. First is AI can be used for predictive maintenance. Now, what is predictive maintenance? It is basically the various conditions of working of an equipment can be monitored by using various sensors, and data analysis and machine learning algorithms can be used to predict when a machine is likely to fail. That is based on the patterns observed over a long time, based on the data. Now, there is another terminology which is called a prescriptive maintenance, of which we did the seminar in MCME. So in prescriptive maintenance, it's just little more than a predictive maintenance. It not only predicts when a failure is likely to occur, but also provides recommendation on the best course of action to prevent or mitigate this failure. Today, in the World Army, if I tell you, because we do not have any AI as such, but USA has been able to, they've got an Army logistic group. They have contracted IBM Watson to incorporate prescriptive maintenance tracker. So each vehicle has got 17 sensors, and this data is monitored and taken concurrently, immediately, analyzed, and then what action is to be done is given. Similarly, contract of Bradley has also been done. Now their MBTR Abraham tank that has got a turbine engine. So they have developed a turbine engine diagnostic artificial neural network. It employs this ANN to perform diagnosis and prognosis of fuel flow problem in the gas turbine. Now, so prescriptive maintenance or predictive maintenance is one aspect in which AI can be used in a big way, but you require certain components for that. Now, what are the components you will require for a prescriptive maintenance? You require a large number of sensors. So I'm just giving, say, for an engine, you will require a temperature sensors to check the oil temperature and coolant temperature, a pressure sensor to check the oil pressure, an accelerometer to check the motion, wherever the motion is there, a torque sensor, it will check the power transfer between any coupling and the shaft, exhaust sensor, it will check the composition of exhaust gas, the oil condition sensors, impurities and gear pattern of engine can be tested from that. The acoustic sensor will also give you identification of various noises. Vibration sensor is another. It will give you the torsional or linear vibration in shafts. Ultrasonic sensor is also what should be the distance between parts, it will tell. And of course, camera for monitoring a lot of things. Now, once you have all these sensors, these are all called them each individual sensors are IoT. So you have this Internet of Things. So you have to be in a network. So you have to have a cloud from where these sensors send this data, and this data is stored in that cloud. And once this data becomes a big data, initially, of course, data will be raw, unstructured. This will have to be cleaned and all. You will have some historical data also, but we know how our historical data is. But if you have a historical data, incorporate that also. As more the data, the AI will be able to analyze along with the current data. So now use a machine learning algorithm by which you can initially you look at some training data to train the machine. After that, based on regression analysis and classification, it will be able to predict what is it going to do. Now, what are the regression analysis will do? It will tell you the remaining useful life of asset, the aging pattern of asset, what will be the consumption pattern of oils and lubes. So what we did is, once we did that, we were able to predict how much this engine is going to live further before it fails. So that is one thing which we were able to do. But how accurate it was, I will not say it was not more than 60-65% accurate, because the amount of data we couldn't get much data. After all, we could do it only in the MCME tanks. And how much can you run? What you require for AI is large amount of data. So if we can fit in a, say, a squadron or a regiment, about 14 tanks, if we can fit all the sensors and run them for a large number of hours and kilometers, then we'll be able to generate a large amount of data, and we'll be able to practically see the prediction is coming correct or not.
General Ghosh, I would request you to see this aspect of building in of sensors in machine learning, what General Narayanan has just spoken about. What is your opinion about it as far as implementing in our area of interest is?
Sir, as far as artificial intelligence goes, it is a digital space which we are talking about. We have been through MRO is such an industry where maintenance costs are going to be determining what kind of technology is to be utilized. It is not that technology has not been used in this particular field of MRO. We have been through the ages from corrective maintenance, where we have operated at failure, to preventive maintenance, where we have scheduled over time periods, be it hours, days, and so on to predictive maintenance, where we have seen condition-based maintenance, which General Narayanan brought out, where you have looked at a certain amount of behavioral pattern of oil or temperatures and others, adding these sensors. Only difference, what was there, and then on to condition monitoring, which was monitoring through sensors. Now, sensors have only grown over a period of time, be it for acoustics or be it your vibration sensors, thermal, solar, wind, wherever, there's so many of them, or pressure. Each can have its own orientation for a particular sector of MRO, wherever we are looking at. Defense sector may be different. But today we have reached a stage where the MRO industry per se is growing. There is a focus on MRO industry. It is likely
General Ghosh, I will just, pardon me for interrupting here, we'll come on to industry, but I will take this point of sensors, because this is, the bottom of the, let me take the views of General Kapoor also. General Kapoor, are you there with us?
Yes.
Yeah. So now, if you have been listening in, General Narayanan has given out, his experience with his actual implementation of these and actually recording it and the limitations as he mentioned. So the aspect of the importance of sensors and data and the accuracy of data, and he said that about 60% accuracy is what they could achieve. So now with a lot of cost goes into bringing sensors in. And if our data is not going to be accurate, our historical data accuracy and our actual data, the ability to resolve it. So there's always a cost balance which comes in, though it's desirable. So may I have your view, because you've written at length on these in many of your articles. Generally on anything related to sensors, data, etc.
Right, sir. Let me start by saying, let me build a technology scenario. And what General Narayanan has alluded to, actually, we also did a similar experiment. In fact, we did it at the same point in time. And we used a torsion vibration sensor. And I would like to just put a little context in place before I get into the prescriptive predictive maintenance. Now, envision a scenario where we have a torsion vibration sensor which is reading from a target called the flywheel. And for a moment, let's take a flywheel with 100 teeth. Now, each teeth is 3.6 degrees, and torsion vibration is a differential equation of multiple order. Let's pick up top 10 harmonics, because the harmonics gives us the health of the system, and each harmonic gives a different parameter. I'll not go into details, but there are adequate research available on that. Now, in one revolution with 100 teeth, even if you pick up one piece of data per harmonic, you got 1,000 data.
But I'm going to interrupt you here, General Kapoor. I'm going to interrupt you here, because this is not the question which I have asked you. Torsional thing we will go at. I want to get your response as to what do you feel this aspect of sensors, putting them into systems, the ability of sensors to pick up data, the existing data. Please respond to that. Then we'll come on to the specific sensors.
In one RPM, you get 1,000 data points. If it is a 1,000 RPM engine, you get 1 million data points, which is humanly impossible to analyze in real time. So today, technology is a compulsion and no longer a choice with data. And it is all big data analytics. And therefore, the key drivers, if I may say, are big data analytics, technology, and I'll dwell on it later if I get the time, and geospatial technologies, because it's all about precision and positioning. And while General Narayan said 65%, in our experiment, which we continue to do, we got 100% accuracy. 100%. Now, let me come to some details. So, therefore, really speaking, if you do good big data analytics, and I told you the kind of data points that get generated every minute, and if you have analysis added to it, there are 5 prerequisites. First is planning of sensors. Second is building your KPIs and a means to track those KPIs, record those KPIs, and analyze those KPIs. And therefore, you need a real-time information management system. The fourth is a research agenda. What are we looking at out of this data? And the last is a digital service, which comprises an onboard computer, and you have a panel which gives you greens, ambers, and reds for every subsystem. So if you're in green, you don't need to bother. If you're in amber, you please start planning as to what are the components you'll need. And moment you touch red, before a breakdown, you could do it, or you may wait for one. So really speaking, there's a huge transition.
I'll interrupt you here, General Kapoor, because you have really summed it up. Now, you see, the picture is emerging that we have to have sensors, we have to have an ability to read that data, we have to have an ability to analyze that data, and we have to have an ability of displaying that data. So this all is coming in for AI to be impacting upon MRO. So, General NP sir, may I request you to just give your views on this particular round of discussion where we have had the aspect of analysis, everything. So there's an element, I'll request you also to look at the element of cost and especially in legacy systems, how do we do it? And because always cost comes in as a balancing factor as to when we want to bring in AI, no doubt it is there in certain developed countries which are much ahead of us. But can, in Indian context, how much of this is really practical as far as the aspect of sensors and accuracy is concerned? NB sir?
Yeah, thank you, Jasprit.
Sir.
This use of mathematics to analyze data and transform it into actionable information, this is a very old, thing which has been on in various armies and, of course, outside in the civil. And if you remember, in the core of EME also, long time back in the 80s, we started with that cave study. So for all along, initially it used to be statistics, which was being used to predict failures. Subsequently came ML, and now there is talk of AI. While the industry, it has got enough resources, enough money to execute all this, and you will be happy to note that a large number of companies in India, be it MNCs or local companies, which are in the field of especially power generation, are using AI tools for predictive maintenance. There is a company in Pune, the Kala Group, which has networked more than 1 lakh, generators and similar systems, refrigeration units and things like that, and they are monitoring it online. You have the Caterpillar doing it here in Noida itself. They have networked about 30,000 machines all over India, earth-moving machines. They have got mining machines which are working in mines and all, and you can see the complete display of the various parameters which people are talking about. Now, cost is, of course, one major issue, but over the years, the costs have really come down. I remember initially when we took on these projects in early 2000 and mid 2000, the cost was very high. Today, the sensor cost has come down to 20,000, 25,000 rupees, the COTS version. Now, all that apart, the biggest problem for incorporating it within our own. And why have most services not used it? If you see, most militaries world over have not used it. Even this talk of the Abrams using it has only come when they went in for this latest upgrade and they called it the digital tank. That is where they are thinking of, monitoring the condition of the gas turbine. Most armies have not been able to use it primarily because our machines don't move. Most of the time in the year, they are just parked in garages. And over the years, people have got used to this practice of preventive maintenance, carrying it out, and then going ahead either with training or conduct of ops and all. So one big issue is this. The second is, of course, our equipment being of the origin of East Europe origin. Most of it is not in a condition to be digitized. Where we want to do it, we find that there is a huge amount of problem on the durability aspect. You mount a sensor, it goes for a 100-kilometer run, and you find that things go awry. So I think that if we want to incorporate this, either we should make it mandatory that, okay, every system which now enters service should be having a controller or should be having a CAN bus wherein these kind of things can be incorporated. But trying to put it in our legacy systems, I think, will not work. Maybe it can be used for a proof of concept or as a technology demonstrator. But beyond that, I feel it is difficult because you will not be able to find the resource. Unless we can justify the operational context of that, the operational need of that. I feel that there is one window where if we can work in an intelligent manner.
May I interrupt you, sir? Please don't mind, sir. But I thought this is a very important point you brought, especially when the vehicles are not moving, they are static, data is not available. And, in our context, how much it can be used. I thought General Narayanan has raised his hand. With your permission, sir, I request him to respond. General Narayanan?
Yes, I'm actually want to say I support what General NB is saying. That is the biggest problem, getting data. Second, regarding legacy equipment, see, like this vibration system which General Anil Kapoor brought up, it was fitted on a BMP. It gave good rating, but we could not fit on a T72. So, unfortunately, these kind of sensors have to be incorporated during the design of the equipment. It becomes very difficult to put it on a legacy equipment. When we did fit, but then there's a problem of stability and other issues are there. So when Kane and Vajra has got large number of sensors, that is the ideal model for AI to be incorporated. It gives you large number of readings. So these data could be taken and ANN could be used and you'll be able to get some analysis out of that. So this is and second factor about the cost. The costs are coming down, there's no doubt. But then fitting for so many equipments, the will go up. And finally, when the equipments are not moving, what are you getting out of it? Not much. That is the point.
That's a very important point. I think, am I right? General Kapoor wants to say something?
Yes, sir. All I want to say is that this issue has been looked at when we did this exercise as to the fact that mostly our equipment sits in garage during peacetime. And what we identified was that there's, in fact, I must mention that the whole cost of a sensor can be as low as even 1,000 rupees, especially the torsion vibration one. And it's quite unobtrusive. That means that it is agnostic of the system. General Narayan mentioned about problems with T72 and T90, but when you pull it out from the flywheel and you're able to, we've been able to achieve it even in T72 and T90. Now, what we did was we actually put a data logger. So what you do is you keep the sensor with the data logger and you don't put the other systems. I mean, it's like having a handheld diagnostic equipment. And in the garage, as you do routine maintenance, you could actually pull out the data from the data logger based on the daily, weekly, or whatever maintenance drills are carried out by that particular unit. And you're able to analyze based on that. So really speaking today, there are a large number of technologies, interventions available, and they've become really affordable. And what I would like to add is that I think there's a paradigm shift. And for critical systems, it'll be a good idea to go ahead with them, because it gives you a very good understanding as to when you should do, if I may say, maintenance, and when you should do replacements. So it gives you a very clear understanding.
Actually, General Kapoor, you have actually taken the next question which was coming to my mind. The way to start, and you have said critical systems, General Narayanan said new systems. So may I come back to General NB, sir? You were mentioning something about industry and how we can maybe start it, sir. General NB, sir?
See, my experience has been that the East European systems are just not designed for digitization. You know, we can have one-off fitment of sensor here and there. And when I look at a machine, see, I have to see the way the industry is using it in the civil is not the way in which I will like to use it in the military. In the military, I feel that, you know, two things are very important. One is full mission capability, which means that all systems up and running. Second is the residual useful life of the whole machine. It's not the engine only. Because for me, the most important thing for a machine deployed at the LAC is not its mobility so much, but its firepower. As long as the firepower is operational, I can use it in a static role. So we have to see, you know, how exactly these systems are to be used. So I feel that we can justify its relevance. Now, which platform to use and all, we can always debate it. Somebody will say East European systems, we have fitted this, we have fitted that. Somebody will say, you know, the new systems are more amenable to it. So that, let's leave that. But I feel where we can use it is, first of all, guaranteeing full mission capability for the duration of the combat pulse. So if you have let's say we envisage a 15 days combat pulse, then whatever system we are fielding, we should have with at least 90% confidence banding that yes, all my subsystems will work, which means the engine, the main armaments, my main surveillance or fire acquisition systems, and miscellaneous system. Now for that, you just don't need to you know, mount a sensor on the flywheel. You need to have current sensors, you'll need to have thermal sensors, you'll need to have vibration sensors, you will need to use the tank's instrumentation. You will also possibly, I will like that, you know, somebody should give me the residual ammunition status. So the operator knows how many of APFSGS he has got, how many of HE he has got, how many of heat he has got. So we will have to configure a system in that manner and bring in both ML and AI to tell me how many of my machines will be able to last this combat pulse.
Yes, so that's
with
actually
90% confidence, you know, level, because 100% is just not possible with 90%.
Mission.
How we can then develop it.
Sir.
Further, if you want, I can you know, talk about the details little later after some other people have given their opinion.
We'll come to that, sir. So what you have said is correct. You see, the General Aggarwal has just joined us. So General Aggarwal, what has happened is that we have still now discussed that the actual experience of General Narayanan, General Kapoor of fitting sensors. We talked about torsional vibration sensor. General NB, and General Kapoor have said that cost of sensors has come down. And the aspect of these sensors being used in the military, there are certain applications available. But now we were focusing on to where we can take it on in you know, our context, and you know, how can we start. So what came out is new equipment. Maybe we can start up with the critical equipment. And so because the aspect of legacy equipment being suitable for upgradation, even let's say in developed countries like M1 Abrams, General NB said that it has come about only in the digital version, maybe not in their legacy. So this is what we have discussed till now. So I will hand over the you know, to you to give your views on these things and tell us what you feel about it. General Aggarwal.
Yeah, good evening, everybody, and thank you, General Matharu. I just heard General NB, and of course, you've summarized a little bit of what others felt about it. Now, I feel that if you got to be looking at using artificial intelligence for MRO, then I've got a slightly different take. These sensors and integrating sensors, pressure sensor, vibration sensor, noise, this, that, and creating a network, I think that approach needs to change with the advent of the generative AI. The generative AI, it gives you much more powerful ways of addressing the problem. If we embed the generative AI systems in our MRO processes, integrate them, then all you require is automation, which is there, which is possible. You require data, and you require generative AI. The sensors, I feel, they are now going to get phased out when you use AI in various applications, whether it is MRO or anywhere else. And sensors, as it is, it was a complicated and not cost-effective proposition for MRO. In any case, in defense, it was hardly being used because of the deployment pattern, vast, populations, and all the associated problems.
But over here, I'll interrupt to ask you, can you please explain what is generative AI? Because I personally don't understand that word very well.
Okay, my knowledge is also whatever little I read. There's no practical on-hand experience to say. But what I read, generative AI means it takes data, takes voluminous data from every possible source, and then it generates output in the form of either video or text or sounds after having analyzed and after having considered everything. And in a way, it is augmenting human intelligence. It is, of course, using the same machine learning algorithms, but instead of assisting human intelligence, now we have reached a stage where we are going to expand or augment human intelligence, okay, or natural intelligence, whatever.
I'll interrupt you here a little bit, General Aggarwal. See, from my understanding, because I've been in preparation for this, listening up a little bit. See, the thing is, there are three things: machine learning, deep learning, and what we call is the present day this Chat GPT type of AI. Yeah. Now, the thing with the machine learning is that it is actually picking up stuff from what it's experiencing, sensor-based basically. And then deep learning is also an extension of that. But then deep learning also is the one which is analyzing the data which has got collected. But the large language models which have just come in with this Chat GPT, actually they are consuming a very large amount of data, and they are predicting. Their basic concept is that based on that data, it is not an intelligent system. It is a system which goes by its own, that logic, that what word should follow which word, and it, gives out something. So, in fact, the critics are saying that sometimes it brings up hallucinations, nothing which is accurate. For example, if you were to tell that AI what medicine you should have, it may give you a hallucination, and which will not be a very happy state. Similarly, if that LLM or the deep learning which you have done predicts a very odd sort of a thing about your engine condition, then your decision making will not take place properly. So I think that level of AI will take some time. So as of now, we are, I think, maybe restricted to machine learning as far as our practicality is concerned. The other aspect of this large amount of data and its analysis, and this is another issue which is yet to be understood fully as to how much cost is involved in that. So on this, I will come to General Ranjit Ghosh. Could you give some opinion on this, General Ghosh?
Sir, I think we have to come back to the basics as what is maintenance cost, which is critical. Now, it depends on the particular type of equipment, military or civil, where there is no redundancy or which is a critical assembly which is not available to you, be it ex import or whatever it is. That particular assembly, if it is high cost, it is critical with no redundancies available, should be subjected to any latest technology which has got prohibitive costs. So that is what actually has to decide. If you look at condition monitoring of the 80s, you had the Boeing gas turbines being subjected to condition monitoring real time through sensors. Today, you look at NASA engines which are being subjected to AI. So it is the criticality and redundancy of a particular assembly which is actually dictating the requirement and the effort which has to be going and the cost and justifying the cost for it. So applying AI to MRO may not be for all types of equipment, maybe for certain very high aviation equipment, army equipment, but which is very critical, and there is nothing available as a fallback option. That is the place where we have to utilize it. How we do it, what sensor, the earlier sensors, today's sensors, generative AI, you have all the options. You have to pick up what suits that particular requirement. And then
So that's very good, actually, Ghosh. Now I'm going to, bring in something else altogether. And this is, what we are, this word edge computing has now come. Now, the problem is that with cloud computing, which was there, now with when the amount of data which we are trying to accumulate, even with the full-fledged internet systems available, the amount of cost it incurs putting this data back into the cloud, analyzing and sending back is so prohibitive that a lot of people are shying away from it. And hence this new term edge computing has come. Now, when we come to our own systems, that is, let's say the battlefield situation, what is communication is always at a huge premium. So I think this needs to be also looked at. General Narayanan, please, your hand is up.
I just want to talk about what General Aggarwal said about generative AI. So generative AI is nothing. You feed the existing data to this. If you feed it a music data, it will generate a new music for you. If you generate even if you feed a video to it, it will generate a new video sequence for you. That's all. Nothing. I mean, it is something like Chat GPT, the generative AI. You see, it is no. It will generate a thesis which no one has ever written. So that is the generative AI, sir. But to say that you don't require the sensors for AI is not possible. After all, for AI you require data. Data you can get only through sensors and nowhere else. Second thing which I want to tell you is where we can use this AI in beautiful ways. So they use thermography.
So just 1 minute, General. Let me request General Aggarwal to give a response to that. General Aggarwal, please.
Yeah, you brought out the point firstly about hallucinations and all that. The generative AI language tools are just about four months old or 5 months old. These are early days. So the same machine which is giving hallucinating answers today, tomorrow or in a very short time will give you very intelligent answers. Okay, so that is the point I'm trying to make. Secondly,
but I disagree with you there, because what the critics are saying that this is being hyped up, and the no amount of data which you put into the LLM, it is going to become any more intelligent. It is not an intelligent system. It is a system which is just predicting which word should follow which word based on the library which it has. So the hallucinations will not go away. This is what critics are saying. I'm not saying, but actual critics are saying. So it is not that by waiting for some time, a totally new system will have to emerge for it to become really intelligent. Like it's not a conscious system. Like a human being looks at a problem and then thinks of so many things and comes up with a response. This is not. So this is an important point. That's why I interrupted you, but I'll try to bring in Ranjit Ghosh because he's done a lot of work.
Let me complete. Let me complete. I'm also reading the experts only. If Bill Gates says that he is highly impressed by the IQ and EI of the Chat GPT kind of generative systems, and they could replace human reasoning and human functioning in most of the things in future, and not only with Bill Gates or Elon Musk or so many other experts. So that is the hallucinating thing. Next time, after a week, the same thing will give you a very intelligent answer. It is also based on machine learning, deep learning, and all. Those algorithms remain the same, but the technology has changed.
No, you see, General Aggarwal, what I am saying here is that the machine learning is slightly different, where it is picking up and then responding. But what I am seeing, and though I defer to very illustrious people saying what they're saying, but the critics are saying what I'm saying. The LLM-based, what we have seen in Chat GPT, which was the response which happened, the hype happened, a lot of people responded, very eminent people responded. That has got its limitations. and they are already coming to the fore because when people are able to trick it. For example, you say they ask a question to that LLM-based model that so and so giving out the gender of the person was there. What is their gender? And it gets confused. So the thing is, because it is LLM has got its limitations. It's not yet.
I'm saying next day or a week later, the same system will give you an intelligent answer. Okay,
fine. There's a question mark on that, but let's agree to disagree on that. Okay, and maybe we can bring in Ranjit Ghosh on that. Ranjit.
Yeah, I'll also like to respond to General Narayanan.
Yeah, please go ahead.
He says there is no data without sensors. I just give an example from our own functioning in the army. We have no sensors as of now, but we have whole amount of data.
I don't say there are no data without sensors.
That age, usage, mileage, and our traditional methods of capturing data. That data itself is sufficient if paired. That this MRO data is paired with an intelligent system or intelligent generative AI system. That itself is sufficient to assist you in MRO, to solve your MRO problems. You require automation. You require a personal assistant, some kind of handheld device or computing device, like we were talking earlier in Project Emerald. Some kind, every operator or every technician has a handheld device, which is a AI-based device. And when he approaches the equipment, it is automated and it gives you answers. If it's a new technician, he says, okay, you have to repair such and such system. These are the steps you follow. It prompts you. Okay, that is a very simple thing. It can be done even today. But predictive maintenance or repair, it has got the capability, because I'll give an example. Let's say any equipment you take the T72 equipment. If over a period of time, that AI assistant has got data not only from your inventory, your own force inventory, but it's got data it can have data from all over the world. And based on the age, usage, mileage, frequency of breakdown, fault analysis, etc., which we cannot do as a human being, we cannot do. We don't, that personal assistant has got a capability, and it will tell you if this equipment is requiring this particular, replacement of a major assembly or spare part, or this fault may occur. So these things, these are early days, but it is expected that the power of the intelligent systems will increase exponentially. And in another 10 years' time, this will be possible. What I'm also, thinking is, just like we had an agricultural revolution and we had a services revolution. In between, we skipped the manufacturing revolution almost. Okay. So similarly, you are going to have what we had, a non-automated system, MRO functioning, and then we struggled with so many years, so many decades. We have struggled with, trying to do automate, connect, network, and all that. And suddenly the solution will emerge. You will change to a intelligent system without requiring the use of sensors. It is highly possible, and I foresee it in future.
Yes, I agree with you. And especially, the point which you made regarding it being an assistant, I think this is something which can happen right away. And this is a very, very important point you make. And I think we have got two hands up. First, General Kapoor, please respond.
Right. So I think it's becoming very interesting to listen in to various views. Now, one is today, most of the expert AI systems, like what General Kapil alluded to, are actually using statistical studies. And one very important one which is being used is an adaptive Kalman filter. In fact, this filter is even predicting failures of banks today. The banks recently that have failed, more than a year back, it was predicted by a adaptive Kalman filter using AI that the trajectory this bank is on is going to fail. And it did happen. So really speaking, there is a change in times where our faith in technology and our trust in technology and our trust in data is very important. And when we say trust in data, I think sensors is a compulsion and no longer a choice. Because I just gave an example when I started, the quantum of data that you can generate from a sensor, it is humanly impossible to really evaluate. It needs and a supportive algorithm to give you the right responses. So that is going to be a new paradigm in MRO when we look at MRO using sensor. And if we don't use it, well, we have a choice. We don't use it today, then you end up paying heavily into periodic and preventive maintenance. And that cost is hell of a lot because we need to look at that.
So
that is
you
one
made
aspect.
a very important point. You know, when you gave the example of banks and you said there is a thing which is there, which is helping, which predicted, that's very important point. That I think is something which can happen. So, but General Ghosh also raised his hand on the same point. Would you like to say something?
Sir, since we are discussing AI and MRO specific, we should look at what are the parts of MRO which can be made conducive to AI, or where AI is conducive to which part of the MRO segment. So what we can presently see is that it is only applicable to the provisioning part where you're demanding certain things and procuring it in time, just in time, depending on what kind of a data has got generated. The automation of the process per se or the automation of the maintenance and operations part will again depend on a specific segment where it is getting employed. However, which is the part of AI which can be utilized today? We all know the applications. The main application which can come up is the machine vision, where you are looking at some kind of a camera which is scanning and picking up very high resolution pictures to identify or detect faults. So it is a very minuscule level of application which can be adapted to MRO today.
Yeah, that's a good point you make, General NB sir. Yes, sir.
No, see, what I like to say is, that it has to be a combination of statistic tools, CVM, as well as AI if you want to have a holistic solution. You can't just say that, all this is unnecessarily, it is not required. Now, I feel that in the military, because I am focusing more on military because we are working in this field, you'll be surprised that we are working on an AI-based health monitoring system, and the experts with whom we are dealing, you'll be surprised the AI, apart from the others, the AI module per se, which he has mentioned, he says there'll be these kind of models which will be, the algos which will be incorporated there. There'll be a performance analysis model, there'll be a health score model, anomaly detection model, probability failure model. This is where statistics comes in, failure cause analysis model, recommendation model, maintenance model, optimization model. So it is a combination of all this, and all this will require data. Now, I feel where we can employ it, first of all, we can use it. The change detection algos which we are using basically in space can be utilized, especially to track the condition of the electronic systems of single shot devices like missiles and all. See, missiles and all, you've seen the success rate of the missiles fired by Russians has been close to about 20-25%. This was the statistics 30 years back also when the Gulf War took place. That time also close to 20% of the total missiles fired only hit the target. Now, with all this improvement, of chip, this, that, and all, we are still in the same situation. So I feel that is where both a thermal measurement of thermal radiations, measurement of current together can be used to at least scan the missile electronics periodically to see what kind. This method of doing the continuity test and all, I think, which the Russians have taught us, may not give us that kind of a result, and possibly we'll also see our missiles going awry. Number one. Number two, in other complex platforms, we can select, like Ghosh was mentioning, we don't have to do across the board, but we can do in 4 or 5, the big 4s or 5s, which we say, of any formation. As a test case, we can take up 300-400 machines and possibly try and reach. Now, for me, what I have visualized is how should this AI assistant or whatever you say is going to work for me. If I was there, I will say, okay, this is the duration for which I need. This is my mission requirement. And you got to first prepare my complete hardware to see that with 90% confidence, this complete big 4 or 5 will be able to perform this mission. If not, you should be able to predict the failure and where the failure will take place, and so that relevant actions can be taken in advance, because if you are forewarned, you are forearmed. And this assistant of mine, in case of a failure which takes place, the assistant of mine should be able to on its own back order the required parts from the logistician on one side. He should be able to warn the technician that, look, you need to move forward and this is where you will need to, your services will be required. And thirdly, he should be able to even warn the op logistics branch that, okay, you may have to look into your WWR, because I visualize that the time these guys will take to repair this whole thing may be beyond the combat pulse. So, it requires a little bit of thinking, and we just can't apply whatever is happening here, there, and all into our system. We have to see exactly what is our requirement. So I think this is how we have to intelligently incorporate AI into a system, and of course, look into the aspect of, we can't just put everything on the cloud. We can't network our systems. So we have to find our own unique solutions based on which, but certainly there is a lot of scope for use of AI in defense. And as I said, that till the time we will not give an operational reason for introducing it, nobody will agree and give you those funds. Even if you require very limited funds, they will not be made available.
Thank you, sir. Thank you. In fact, General Narayanan has got his hand up. General Narayanan, please. And after that, General Ghosh.
So, one more thing which I wanted to bring out is that how you can use it in MRO basically for repair. In a suspension system of a tank, everything you can make out other than the bearing. Whether the bearing is going to fail, when is it going to fail? We had used a thermographic camera, we fitted it on it, and based on that, and I mean, of course, we used the IoT and everything, we got it transmitted. When it was moving, we could make out that now another so many kilometers will fail. So these are the kinds where AI could be utilized in a big way to fit in our tanks. Even these legacy systems also can be fitted. I mean, these also can be fitted. So it is not that AI cannot be used in a big way. We can use them. What we were also visualizing is that, all our sensors should be clip-on sensors. So that, a tank comes to the workshop, you put on this clip-on sensors, connect it to the software and move the tank. And now it should be able to tell us what are the faults, which are the things we are going to fail. This is the kind of system which actually we can develop.
Yes, that's very, very, very interesting the way you said clip-on sensors. Yeah, certainly I think data collection will become much easier. General Ghosh?
Sir, I agree with General NV in all the points that there has to be a mix of predictive, prescriptive, condition monitoring or AI. So as General Narayanan brought out, you require strap-on sensors for a dynamic system, and dynamic system has got its own harmonics, as Gen Kapil brought out, and each harmonic gives certain indications. So, and it requires a lot of collusion effort in terms of recording your baseline signatures and then recording a real-time digital information coming in, then superimposing it, then inferring, and then triggering an alarm to sort of predict a particular requirement. So it has to be a mix. It has to be a dynamic versus static. There are a whole lot of combinations in which AI specific has to get implemented into MRO or equipment or any sector as such.
Thank you. General NB wants to say something, sir. Yes.
I feel that, these vibration sensors or torsional vibration sensors, they may not work in our context, especially if we are looking for clamp-on sensors. So clamp-on sensors, the best place to do it is the high pressure lines of the fuel injection system for the engine. And second is measuring the change in current. Because I feel that if you can measure the cylinder-wise, if you can measure the current drawn by each cylinder during the cranking process, that will give you an indication as to which cylinder is in what state. You can see, you can get a graph like a ECG, each cylinder-wise, that one cylinder, this is what is the current being drawn, second this, and from there. So this is how we have to do, because vibration sensors, the nature of the sensor is such that it cannot be a clamp-on sensor. It has to be rigidly mounted there, then only it will last that duration of the run. So these are things, which we have to think, and we have to actually create a a desi model. We just can't, while picking up information here and there from others is good. We certainly need that. But we will have to create our own model of working. And I'm not saying, when I say we, I'm talking about all armies also. Other armies also will have to work on that. If they think that they will mount a vibration sensor in a tank, and that will lifelong it will be there and keep giving you data, they're sadly mistaken. Because
thank you.
You have to see the condition in which the machine operates.
Sir.
That also has
so
to
Gen Kapur sir wants to, I think he's raised his hand, he wants to respond or want to give some points on that. Go ahead, Gen Kapur.
Yes, sir. I think very interesting again what General Ghosh brought out. Actually, we did a little study on this, sir. And since we are doing an ideation session in this MRO, AI in MRO, we did this ideation. And for a tank, in fact, I must before that say that today everything is very modular. And we've got a large number of internal protocols like LEN, CAS, most. I wouldn't like to go into those details, but there are a lot of bus-based and wireless protocols available in equipment, which can be actually hooked onto a data logger. And why I'm highlighting a data logger is because perhaps that's the best way forward for us. And we came up with a thing called shape in tank, like shape for us. Suspension is one zone, hull is one zone, armament is one zone, part pack is one zone, and electronics is one zone. So we looked at these 5 zones. And I think as an experiment, we've given this experiment that let's look at various sensors that can be used in these and look at an optimum effect of these sensors, firstly as a technology demonstrator, and then identify criticalities where we would like to replicate and when and in what time frame and what cost and all that. So it was a very interesting exercise we did. And I think there is a huge future in this. And I'd like to bring it to your notice, sir, that to notice of everybody, that Indian Navy has gone for CBM in a very, very big way because they go for showing the flag abroad. And therefore, they do a huge deliberate exercise of diligence in MRO requirements, because earlier they were carrying almost everything under the sun to meet for their contingencies, something that we call periodic and preventive maintenance. Now, based on prescriptive and predictive requirements, they carry what they feel they will need based on these sensors. I think there is a huge future here, and AI will become a great enabler. In fact, it will become inevitable for us to use AI, given the volume of data that we'll get with these sensors. That's all I wanted to bring to the note.
Now, I would like to hand over to General Kapil Aggarwal with that. They also request him that after what he says, what he has to say, then he can kindly give his closing remarks, because I think then after that we will start. I'll come to each panelist, and then finally I'll come to General NP in the end to from this, and maybe if you can indicate which is the immediate areas where we can start addressing AI in MRO. General Aggarwal, please.
Yeah, thank you, General Makaru. First, General NB had very nicely covered all the applications and all the jobs which a personal assistant or a AI assistant will be required to do, whether it is detecting a fault or predicting a fault or doing ordering a part or predicting where the bottleneck is going to be in the supply chain. All those things are possible. And my point basically is that we are shifting to a different level of AI from now onwards. Dr. Paul Grumble, a leading exponent of AI, he says that digital age is already over. In 2023, we have entered the augmented age. And with the generative AI tools and much more to come, things are going to change beyond recognition. What you require is data and data and data. Where you get the data from, initially it could be traditional methods like we have, purely automated. It could be augmented by data from the sensors. And then for each equipment, each this thing, there is when sufficient data is collated, then dependence will be more and more on statistical models, and it will be able to predict almost everything with a high degree of accuracy. So in future, the more and more emphasis is going to be on statistical models, and that future, what people, experts feel is not very far. It could be at best be a decade, because now it's going to be exponential growth. And in fact, the growth is to that extent that some bigwigs, the same bigwigs who were enamored of AI, whether it is Bill Gates or Elon Musk, now they're talking of the need to regulate AI, because it is going much beyond human intelligence. It is going much beyond natural intelligence. You know, like what General Ghosh and General Narayanan brought out, that so many things will have to be done, analyze, integrated, this and that. It takes time for a normal automated system also. But this kind of AI which we are perceiving, you know, which will happen, which is going to happen very shortly, the things are going to happen in a jiffy. All you require is data. And once the data set is complete, it can predict everything. And each facet of MRO, it will be a game changer. All at the cost of repetition, all you require is an automated system, a personal assistant available with each operator or a technician, and you're good to go.
Thank you. So now, General Ghosh, your closing remarks, please.
As far as what I foresee the future of AI, we have seen AI right from the term being coined in the 50s till today, which is 70 years. And as General Aggarwal brought out, there will be exponential applications which will come up. Presently, the applications of whatever we have just discussed in terms of a chat GPT or is also not, it's a conversational AI, which is also not being, there's no truth in it as of now, as far as Elon Musk is concerned. He's saying, I'll come out with a truth to GPT. So there is a long way to go, but yes, the potential is tremendous in terms of AI application, and it is going to surely evolve, and how well we can apply it to our MRO context, only future will tell us.
Thank you very much, General Ghosh. And now may I request General Narayanan, please, you can give your closing remarks.
I still feel, sir, that as a core of EME, we should ensure that some sort of AI is there for the workshop to, analyze and diagnose the equipment. So the thermography is one which you can be utilized by the workshops to detect which part is heated, and AI will be able to do that. Similarly, if you can work on the clip-on sensors and with the requisite software, we will be able to, predict the future of the equipment. And third thing is somewhere data analytics and AI could be utilized in a big way for spare parts management, which is another area which is critical for us. Thank you, sir.
Thank you very much, General Narayanan. General Kapoor, may I request you to give your closing feelings about thoughts which you have?
Right. I think AI in MRO is a reality in the near future. And I'd like to say that the 5 pillars, in addition to the 6 pillars of sustainment, each pillar will firstly get impacted. The 5 pillars, first is planning. We need to plan in every pillar, how do we want to bring in AI, including in equipment. Second is we need to build KPIs and tracking mechanisms, whether it is buses or wireless systems. Third is we need to build a real-time info management system to read whatever is there. And of course, a research agenda, because this is something that will require a lot of research, especially when we look at MRO, given the wide spectrum of equipment and systems that are there. And last is, it will be based on, we should have a simple display systems, which will also need to be generated to be able to derive maximum benefit out of the AI data and the system of carrying out predictive, prescriptive maintenance.
Thank you very much, General Kapoor, for those, giving a way forward. General Bisa, may I request you to give the final closing remarks?
Yeah. See, I feel that, AI should end up spotlighting, first of all, the likelihood of failure of a platform at a platform level, be it a missile, be it an aircraft, be it a land system. So that is very important, because that is where, if we really want to use AI in the military, in MRO practices, that should be one of the outcomes we should seek. Second, of course, is inventory optimization. I feel that we need to graduate to readiness-based pairing. And to give you an example, in the case of Abrams tank, by using this concept, they have come down from about 3,000 parts, which they used to stock, to roughly about 400 parts. So imagine, the advantages of this small inventory being carried by our mobile echelon, especially the IRG and the EBC, etc. Then last, of course, will be to optimize cost, because I feel in this whole thing, unlike the civil industry where managing cost is the first criteria, in our case, it should be the last. But yes, optimization of cost is important. One area which will require attention is upskilling of our HR. Then, of course, whether it's a wireless system or it's a system which is a wired system using a data logger and all that, we have to beware of the risk and manage risk, because data security is important. And here I will end on the note by giving you an example of how this digital bomb can be used in a platform which is digitized. Now, imagine a condition where you are preparing for a cold start, and there is one guy who just comes and introduces a malware, which he just says, okay, after 3 days, moment there's a whole lot of my formation will reach the projection area, all the tank engines will get into the high-speed mode, because you got a controller. So I've introduced a software which ensures that all the engines start screaming. And that's the time you got to, at the projection area, you need to be silent, you need to be, and here all your complete armored brigade is, creating this chaos. What happens then? There is no way, there is no way for the operator to control it, because the whole system is all wired and it's being operated by a chip. So this digital bomb, this is also an area where we have to be careful. And that is why whatever we implement, it has to be an end-to-end solution, taking into account all aspects which a military needs to address, to keep its operational effectiveness intact. Thank you.
Thank you very much, sir. That's you have brought out this aspect of the threats which will come along with, like General Aggarwal said, from digital we are going into this new AI form. It will bring its new type of threats, and we have always seen that these are coming in and they come as surprise. In digital area, there was a zero-day exploit.
You never know the assistant he was talking about, if he just orders them, okay, all tanks to get into high-speed mode. Then what happens? Then all of them will get into that. Like Alexa keeps, doing things.
Your point is valid, sir. Your point is valid. And a lot of work is on this cyber, because this is the biggest threat to software-defined systems. That how do you break them? Cyber and even electronic warfare. In fact, they call it cybertronics these days. And there's a lot of cybertronics hardening, which is a good area of research. Thank you.
So in fact, you have given us a topic for the next panel. Pardon?
What I'm trying to say is human interface will be there. It is not that the chip will drive the tank or something.
But that human interface should not be the guy who just raises his hand. He's the guy who knows how to address the problem.
The tank crew would still be there. I'm not saying, I'm not dispensing, I'm not seeing that tank crew would be dispensed with and only your assistant will, drive the tanks. The human interface will still be there. To that extent, it will still be a hybrid system.
No doubt. And on that point, I think we can close by saying that if you do not go in for AI, then you lose your in the case of an organization, the competitive edge, and in the case of an army, the battle edge. And that is something which we can ill afford. And I think since in MRO, we are all engineers, maybe we should take the lead of bringing in AI in whatever manner we can. And I think anybody who's listening in, who are presently, are taking such decisions, will certainly, with this very wise panel which we have with so many years of experience, and you have shared your views so openly to guide. Maybe this will guide people to look at the right directions. one thing is clear. You need AI because without that, you will get left behind. So I think that's a little takeaway we can do from this. I would now like to close this seminar because it's been a wonderful interaction. And for me personally, listening to all of you, very wonderful panelists, and we could maybe have another seminar into the sub areas which have emerged out of this seminar, and we look forward to that. So with that, viewers, we come to an end to this particular panel discussion, and we look forward to seeing you in our future panel discussions. And you may like to listen to all the other panel discussions and other videos we have. The links to the panelists' profiles will be there in the show notes. If you want further clarifications, you can approach them through their profiles. And with that, I will close the panel discussion after thanking all the panelists for sharing such expert views with us today. Thank you, everybody.
Thanks. And
Jai Hind.